This question is asking you to compute the average velocity in the following two cases. The first one is that you walk 73.2 meters at a speed of 1.22 meters per second and then run 73.2 meters at a speed of 3.05 meters per second along a straight track. So let's try part A first. Let's say we have point A here, and then point B, and point C. The first part is 73.2 meters, and you are going at 1.22 meters per second from A to B. And then from B to C it is again 73.2 meters, but the speed is 3.05 meters per second. So let's just try to find the average velocity. So we know that average velocity is displacement over time. But we need to do this from A to B and then from B to C. So from A to B, we have our time, let's say TAB, which is equal to the displacement over the velocity. So displacement is 73.2 meters, and then the velocity is 1.22 meters per second. So that gives us TAB equals 60 seconds. And you see that the meters cancel here and the per second goes to the numerator. So that is TAB. Now let's do T of BC. And that is again displacement, which is 73.2 meters divided by the velocity, which is 3.05 meters per second, and that's going to give us 73.2 divided by 3.05 is going to give us 24 seconds. So let's just go back to our equation here. So from here we have delta x. So this delta x is from A to C. So we need A to B plus B to C displacement. So A to B is 73.2 meters, and then B to C is 73.2 meters, and then the total time takes is TAB plus TBC. So we have 60 seconds, and then we have 24 seconds. So that gives us V average equals 1.74 meters per second. So that is the first part. The second part is asking a similar question. You walk for 1 minute. So now they are giving you the time at a speed of 1.22 meters per second, and then run for 1 minute at 3.505 meters per second along a straight track. So let's just do part B now. So we have 1.22 meters per second and 1 minute, so that is 60 seconds. And the second part is 3.05 meters per second, and that is for 60 seconds. So as you can see, what they're looking for here is average velocity, but they are giving you the velocity for each segment and the time for each segment, and that's different from part A where they are giving you the displacement. So let's just try to find the average for each segment. So here we have our delta x, which is equal to our V average times our delta t. So this is 1.22 meters per second times 60 seconds, and you can see how the seconds cancel, and this gives us 73.2 meters, and this is from A to B. This is delta x AB, and then for BC we again have V average times delta t. So we have 3.05 meters per second times our 60 seconds. So delta x BC is 183 meters. So if you go back and look at the total V average, which is delta x over delta t. So delta x is delta x AB and delta x BC. So we have 73.2 plus 183 meters over the total time, which is 60 seconds plus 60 seconds. So that gives us V average equals 2.1 meters per second.